All right, ninjas, let's get back to work. This is another one in our Absolute Beginner series, denoted by this 8 Caillou ranking, and it's called Double Char. Given a string, I should say char is short for character if you were wondering. Given a string, you have to return a string in which each character, case sensitive, is repeated once. Let's go to the examples. Capital S string. Notice how you basically spell out string again, but each character is duplicated, SSTTRR. And you can see that happening with the other examples. Note that case matters. I can't follow a capital H with a lowercase h. That applies to letters, obviously, and not numbers as we see below. But yeah, I mean, strings can be anything. We usually think of them as words like this, but you could type out any character your keyboard will produce and make gibberish strings like this. So I think that's very clear. This is a good one for beginners. You should be able to come up with a pretty good idea on how to execute this one. So why don't you pause the video and do that, and then I'll knock out a quick solution. So how do we want to think of this? Well, we know we have to return a string, right? That's what our method contract says. They're going to give us input string, and they expect back from us, right? That's what our method is. It's an agreement between us, the implementer of the method, and people outside, which may call our method. And that's sometimes us too, right? We call our own methods and we provide our own solutions. But it doesn't have to be that way. So you can think of a string actually as at the end of the day, it's just a collection of characters. You know, it might be implemented as a character array. You could go look up the implementation of the string class if you wanted more information on that. But you could think of it as a sort of syntactic sugar that just makes it easier to work with. So instead of always having to work with a character array, you know, we've worked with arrays some. They're these fixed size collections where all the elements are of the same type, in this case characters. You can use this string class. You know, someone was nice enough to make that, and they included by default with the language, so you don't need to bring any libraries to use it. It's one of those basic types like int and double and float that we get, and it's a little easier to work with because we don't have to worry about, in the case of arrays, right, they're a fixed size. So what happens when you want to make a string have a new value that's a larger size? I mean, under the hood, right, you've got to resize that collection somehow, and other underlying data structures can be better suited to that. You can look up the string class if you want to see how they do it. It's just nice for us that we have it, we can use it in a simple way, and we don't even need to be bothered with the details of it unless we want to be. So hopefully that gives a little more insight on the string class. We'll go right to it. So what's the strategy here? We're going to get a string like this, like string. And sometimes when you're solving these problems, it helps to look at it, think, you know, how would I do this in a real world? Imagine I gave you a bunch of alphabet blocks or letter magnets, right, that were going to spell out some word or just some gibberish thing that I wanted. You know, what would you do with that? You know, imagine you have this big pool of letters, extra letters laying around too. Would you line up the word and then start from the left and match each letter and build a new string below it with your extra tiles? Would you insert the duplicated letter right within the string you were passed in? You know, you just think, you know, how would I do this, to get an idea sometimes. So for me, I'm going to build an extra string, right? I don't want to modify this input because I'm going to be counting on the input to know which letters I'm going over. And so if I'm modifying that each time, then it kind of complicates that process of scanning through the input string. And so, right, memory's cheap. We have tons of it. Why not just create another string variable where we'll sort of construct our result, right? So you can name variables however you like. I'm just setting it up to be empty. And then we know we can scan the input and sort of just keep tacking it on. We can append it to this result and build it as we go. So we know about for loops. You can use a for each style, or you could use a regular for loop where you provide an index value. In this case, I like this one a little bit better. So let's go char, again, a variable name. I'll just call it ch for short, in s. And so what are we going to do, right? We thought about it when we had those, when we were thinking about this with the letter blocks. You know, you're basically going to scan each letter, find an extra letter of the same type, matching case if necessary, and just put it in the result, right? So we know with result, we've got the shorthand for concatenate to append to the end, right? But you could also say result equals result plus if you wanted. I like the shorthand better. Char, and then basically you just want to take the exact same char, right? You don't even have to think about casing or anything if you just use the exact same character. Now, this won't quite work because notice that the result type is a string and we're looking at these as characters. So to keep everything as strings to match types, I'm going to use this toString method that all objects have. And in the case of characters, it works out okay. Now notice if you make your own custom types and call toString on them and don't override the base implementation, you just call it to see what it does. It may not always do what you want it to. It won't, you know. But in this case, it will convert the char. So remember, chars have single quotes around them. There's an example of a char. There's an example of a char. Let me move my cursor for you. Like that, right? It's just a single character, right? Whereas strings, you can't do this with a char, right? That's more than one character. But with strings, you can. And they're denoted by double quotes. I can do this with a string. Those are valid strings. So that's how you know the difference. And so yeah, we basically duplicated it, right? We said whatever character's there, take it once, and then just add the same thing again. And then you can imagine this for each loop goes through every character in the input. You know, it's looping each time. 1 iteration, 2, comes back to the top, executes this, back to the top, executes this, back to the top, each time incrementing the character. For each takes care of that for us. And you remember with the regular for loop, it has an index. You know, we would go int I equals 0, I is less than string.length, plus plus I. And then you're kind of explicitly incrementing it. And then finally, after you've processed all the letters, you can simply return your result, right? So let's take a look, see if that's okay. And it looks good. We got our green. We'll go ahead and hit that attempt. But yeah, just thinking about the problem, right? Like you could have, if you just think differently, you could have processed the string from the right, but you would have to, you know what I mean? You wouldn't always be appending to the end. You'd have to insert from the front in that case. But it's just, you know, thinking about what makes sense in your mind, what's easiest to do given the language features that you have. So I think this was a pretty straightforward way to think about that problem. But I'll go ahead and hit the attempt before we claim victory. There's often a number of times where you'll hit that larger suite and you'll find some bug that you didn't anticipate. But we hit it here, so I'll go ahead and submit, get our honor points. You know, of course, to look through the other solutions to see how other people did this thing. And let's do that. So there you go. String join's nice. It's using the select method. You can go to that enumerable class again, remember, for the kind of the link stuff. We've looked at that in the past. Let's see if I still have that here for you. So remember, we went under enumerable methods and you got all these nice methods you can use with link. And they use select, which is a very common one. So yeah, that should give you some good ideas projects each element of a sequence into a new form, right? Very general, incredibly useful. You can imagine this being relevant in a lot of work that you do. So yeah, great answer. Nice one-liner. People love the one-liners. They use the string builder class. That's nice too. That's a nice touch. That's great if you're going to modify strings a lot. Remember, we kind of hinted at how strings are implemented, and if they are as an array, you've got that issue of what happens when the string size changes. You know, are you throwing away memory, reallocating a larger chunk that's sized to fit your new word or text? And you can imagine that can be expensive if you're constantly changing the string. So there's classes like this string builder that would be an implementation of a string that's more optimized for changing size. And so this is great, right? Now you've got another rabbit hole you can go down. Hey, what's this string builder thing? You go read about that, you know, and you're expanding your mind each time. Here's pretty much what we did. I didn't quite follow the empty string plus C. Not sure why they needed the empty string there, but that's basically what we did. There you go. There's a nice concat with select. I think the other one used string join. And yeah, that's good stuff. This is a nice format here where you put your variable inside these curly braces. I think they call that string interpolation. And it will, you know, instead of printing an actual X, it'll be whatever the value of X is. It knows to insert the actual value in there. So you'll use that a lot. I went with rejects there. Okay, cool. Aggregate, yeah. Yeah, so lots of link kind of stuff. Feel free to explore that all you like. It's just definitely good content there. This would be a good one to look at other people's solutions for. But other than that, you know what to do. Hit me up with questions. Otherwise, I'll see you in the next challenge. Thanks.